Hello guys, I've been receiving a lot of transformer winding related questions lately, and I've made a short PDF just to show you and explain in more detail those questions. So Justina will help read out the questions one by one, and I will give a short answer. First question.
What is the transformer core cross-section?
The transformer core cross-section is the same as the bobbin cross-section, so this area here. So it would be this, the center leg of the transformer lamination, times the height of the stack. So sometimes it's the same. If the stack is a square stack, then you would have just this squared. But in this case, and in most cases for the power transformers, you will have a higher stack height than this dimension. So it will be this times this. Or if you look at the laminations themselves, so if we take the laminations out, so you would have this or this times this. Okay? Next question.
Second question. What is the window area or window cross-section?
So the window area or the window cross-section is not used for calculating the number, so it doesn't have anything to do with number of turns or the voltages you will get. We just use this measurement to make sure that the wire will fit the bobbin. So if you look through here, you can see that it's this slot looks like a window. We have two of them, and of course we just need these two dimensions. So this, which is, if you turn it upside down, it would be the height. So this is like a window height, and this would be the window width, the smaller one. And yeah, so, and we just need one because the wire goes around, so we just calculate it with a formula for one. Next question.
Does wire thickness affect the number of turns?
The wire thickness does not affect the number of turns or the voltages we would get. The only thing that the wire thickness is responsible for is to make sure that the current rating of the winding is met, so that the wire would not overheat. And of course, if we would use a thinner wire than calculated, then the wire would overheat or heat more than it should, and we would get a higher voltage drop and bigger losses. So the voltage might drop a couple of fractions of the volt or a couple of volts on the higher voltage windings. Next question.
Can I use single coat enameled wire for transformers?
Absolutely not. So I would not suggest using single coat enameled wire, maybe for some input transformers or lower current, lower voltage output transformers, but for mains transformers or power transformers or most of the output transformers, I would just stick to the dual coated enameled wire made for motors and transformers.
Should I use layer of insulation, paper or tape after each layer of each winding?
So if you use the modern motor or transformer wire, which is dual coated, dual enamel coated, that wire is made in such a way with modern lacquers and materials that the insulation is extremely durable, and it can withstand several kilovolts. You don't have to use it with these modern techniques, only to isolate primary from the secondary in the mains transformer. But in general, you don't need to use it as it goes for insulation. The only reason you would want to use it is to make the windings more neat. So if you put a thin piece of paper after each layer, you can make uniform layers which are easier to wind nicely on the top of each other. So for that reason, I would suggest using the thin wire if you want to keep, especially for output transformers.
Everything in your calculators is clear, but I don't know what value to use for magnetic flux density.
Yes, magnetic flux density is probably the most complicated thing to understand, but it's easier if you just think of it as resolution of the magnetic core. So depending on the alloys used and the properties of the magnetic core laminations, it can withstand different amounts of magnetic flux density. So if we have power transformers, for the default value we use, if you don't know anything about the properties of the core you have, you can just put the default value of 1 Tesla or 10,000 GS, which is which will work for every core that you get your hands on. And even if the core is better than that, it will still work if you calculate it for 10,000, and it will work even better, and it will not overheat. But if you have newer production of higher grade transformer laminations like M6 or something similar, then you would have a lot higher resolution, let's say. So you could use higher number, like 12,000 or 14, 15,000 even. For output transformers, it's a little bit different, because we have, for single-ended transformers, we have the DC magnetization of the core. So you would use more conservative values like 4,000 GS, or let's say between 4,000 and 6,000. For push-pull output transformers, you would use between 6,000 and 10,000. And for power transformers, as we said, you can use anything in between of 10,000 upwards of 15,000 GS or 1.5 Tesla. So yeah, if you absolutely are not sure what kind of laminations you have, just put the default value and it will be all right. Okay, so I think we ran out of questions for this Q&A session. If you have any kind of transformer related questions, you can post it down in the comment section below, and we will prepare another video for you to try to answer all your questions. Thanks for watching.